This video, we're going to pick up where we left off, starting with section 2.3 topics, which talk about velocities and marginals. Those are important applications of derivatives. But our first topic here is actually going to be finding rates of change and comparing the average rate of change to the instantaneous rate of change. We just learned about the instantaneous rate of change, which is the derivative. The average rate of change is the difference quotient, or the it's this formula. So the average rate of change of the function f of x on the closed interval a to b is f of b minus f of a over b minus a. It's our good old slope formula, y2 minus y1 over x2 minus x1. We're just going to have to calculate f of b and f of a to be able to subtract them, because we're not given our y values, we're given the function and the x values to be able to calculate those y values. So let's start with number 5, and you'll see here something that we're going to call the intermediate value theorem, or the mean value theorem, where the average rate of change for these functions that are continuous on these intervals here are going to be the average rate of change is going to be between the instantaneous rate of change from the two endpoints. That probably sounds confusing right now until I start showing you examples. So let's go ahead and jump into it. So our h of x function is equal to x squared minus 4x plus 2. And we want the closed interval -2 to 2. It is continuous on this interval because polynomials are continuous on their entire domain. This is just a subset of that domain because the polynomial x squared minus 4x plus 2 is continuous for all real numbers, since that is its domain. So let's go ahead and find h of 2 minus h of -2 over 2 minus -2. That's going to be 2 squared is 4 minus 4 times 2, that's minus 8, plus 2. And then minus, when I stick in -2, -2 squared is 4. -4 times -2 is a positive 8, and then plus 2, and all that gets divided by 2 plus 2. This is going to be equal to -4 plus 2 is a -2, minus 4 plus 8 is 12, plus 2 is 14, over 2 plus 2 is 4. This is a -16 over 4 is a -4. Let's go ahead and find our derivative h prime of x now using our power rule. 2 times 1 is 2, and drop that exponent by 1. 1 times -4 is -4. Drop the exponent by 1 is x to the 0. So I don't write that because that's just a 1. Now we can go ahead and substitute h prime of -2. It's going to be 2 times -2 minus 4, which will be a -4 minus 4 is a -8. And h prime of +2 is going to be 2 times 2 minus 4 is 4 minus 4 is equal to 0. And even though they didn't tell you to explicitly do this, what they mean when they say compare the values is they want you to see that -4 is in between 0 and -8. It doesn't need to be halfway in between. It just needs to be somewhere in between 0 and -8. So there you have it. That is an example of the intermediate value theorem, or the mean value theorem, which says that we need to have this this average value be somewhere in between the value of the instantaneous value of the endpoints. Let's look now at number 7. And number 7 says f of x is equal to 3x to the 4 thirds. And it's on the closed interval 1 to 8. Now, I can't use the mean value theorem here to tell me necessarily what's going on. Actually, yes, I can, because both the function and its derivative are continuous from 1 to 8. The discontinuity is at x equals 0, which is not in my interval. But I have to be careful about if the function or the derivative of the function are undefined in the given interval. So I'm good. So let's try f of 8 minus f of 1 over 8 minus 1 is going to be 3 times 8 to the 4 thirds minus 3 times 1 to the 4 thirds over 8 minus 1 is 7. This is 3 times, and then the cube root of 8 is 2 to the 4th minus 3 times the cube root of 1 is 1 to the 4th over 7. 3 comes out as a common factor here. 2 to the 4th is 16 minus 1 to the 4th is 1 over 7. So this is 3 times 15 over 7 is 45 over 7. It's somewhere bigger than 6, but less than 7. So it's 6 3/7. So f prime here is 3 times 4 thirds x to the 4 thirds minus 1 is 3 thirds. So that is 4x to the 1/3 power. F prime of 1 is equal to 4 times 1 to the 1/3. Cube root of 1 is 1. 4 times 1 is 4. F prime of 8 is equal to 4 times 8 to the 1/3 power. The cube root of 8 is 2. 4 times 2 is 8. And 6 3/7 is somewhere between 4 and 8. Again, it doesn't need to be halfway in between. It just needs to be in between. And if you have any confusion about if this function is smooth and continuous on this interval, you can go ahead and graph it on that interval to see that while there is a sharp point at this curve, I'm not going to be able to draw it exactly, but it's related to the type of function that has a cusp in it that we talked about with an even over an odd power. It's related to that type of a function. Then so I'll draw an example of that type of a function here, like that. From 1 to 8, this piece of the curve is smooth and continuous. I don't have to worry about the fact that it's not smooth at 0. All right. One more problem for this video will be number 9. And number 9 is f of x is equal to 1 over x. And we are on the interval from 1 to 5. So again, although there is a discontinuity at x equals 0 here, we're talking about just this piece from 1 to 5, and that piece of the curve is smooth and continuous. So I'm in good shape. The mean value theorem, the intermediate value theorem will apply here. So f of 5 minus f of 1 over 5 minus 1 is 1/5 minus 1 over 1 is 1. 5 minus 1 is 4. So this is 1/5 minus 5/5 divided by 4 is negative 4/5 times, and this is 4 over 1, so that makes 1 over 4. 4 goes into 4 one time, leaving me with a negative 1/5 as my slope of my secant line, my average rate of change. F prime of x, well, I'm going to want to think of this as x to the negative first power to be able to take its derivative. So that's going to make it a negative x to the second power, to the negative second power, which will become a negative 1 over x to the second power, like so. And I'm going to go ahead now and plug in f prime of 1 is a negative 1 over 1 squared. It's a negative 1 over 1, which is a negative 1. And f prime of 5 is a negative 1 over 5 squared, is a negative 1 over 25. And negative 1/5 is between negative 1 over 25 and a negative 1. So if you wanted to make everything a common denominator, this is negative 25 over 25, and this is a negative 5 over 25, and negative 5 is between negative 1 and negative 25. So just think of them all with common denominators if you need to prove the intermediate value theorem to yourself there. All right, that's it for, no, I got another one still. Thought I was done. Got one more for you. I still got number 11. So this is going to be a function of t this time. Don't let that fool you that it's t's instead of x's. This is t to the fourth minus 2t squared. It's a polynomial again, so I know that it's smooth and continuous on its entire domain from -2 to -1. And so I'm going to want to find f of -1 minus f of -2 over -1 minus a -2 is going to be a -1 to the fourth is 1 minus 2 times 1 is 2 minus, and then -2 to the fourth is 16 minus 2 times 4 is 8 over -1 plus 2. So that is a -1 minus 8 over 1 is a -9 over 1 is a -9. Let's look at f prime of t, and that should be 4t to the third minus 4t. 4 times 1 is 4, drop the exponent by 1. 2 times -2 is -4, drop the exponent by 1. F prime of -2 is 4 times -2 to the third power minus 4 times -2. That will be a 4 times a -8 plus 8. We'll pull the 8 out here, is 4 times -1 plus 1 is going to give me 8 times -4 plus 1 is 8 times a -3 is a -24. F prime of -2. sorry, we just did -2 of -1 is going to be 4 times -1 to the third minus 4 times -1 is going to be 4 times -1 plus 4. Again, I'll pull the 4 out. That's -1 plus 1. That's 0. So that's 0. And -9 is between -24 and 0, which is what we expected. So let's end our discussion there. Let me see what we have next. Yeah, let's end our discussion there. You have number 13 to do that includes a graph in your suggested problems. I'm not going to do that one here, but you can go ahead and try that one on your own. It's quite challenging with the graphs to get the average rate of change that you want to find those exact points. I recommend, if you have the online textbook, that you zoom in a lot on the picture for that one. It's like that, and then they're actually going to specifically have you work through the mean value theorem there to try and find approximately where you have an interval where you want the instantaneous rate of change at t=8. You want an interval that has the same rate of change. You can come up with different answers, but let me draw you a picture for what they're trying to get at there. Just roughly is that if I have a curve like this, and let's say that 8 is here. I'm not saying that it is on your picture, but you have that. Find a secant line with the same slope. So maybe from there to there, not even drawing that well, maybe there to there, something that's parallel. So I'm trying to figure out, if there's parallel lines here. So it's coming down here and it's coming down over here, and from this point to that point right there, kind of making up my curve to fit my answer, that I can pick 2 points on the curve that this line and this tangent line have the same slope. That's what they're going for. It's really a challenging problem to do with a graph, which is why I'm not going to try and do it with my bad drawing. But I'm going to do, so leave that one for you to do. Ask your teacher about problem number 13 if you need help with it. But I'm going to move on to the next topic next time, which is going to be to start talking about velocities as rates of change, and those usually have to do with time changing. So velocities normally are something per unit of time. So we'll come back and we'll talk about that next time. So see you for the next video.